Okie dokie. Let's play some more. Oh, there's already another cutscene right there. Absolute positivity. Haha. Wait, what did he say? Smiling is mandatory? Send each thing from the inbox to the outbox, but if it is negative, remove the negative sign first. So, let's say, let's just do one step at a time. So, negative. Unfortunately, you can't type. This is kind of just a mouse-only game. And you can also play it on your phone. Positive. So, let's just worry about this for now. If it's not negative, we just throw it to the outbox and reset. If it is negative, jump if negative, just start here. How do we unnegative it? Well, if we have -7, if we subtract -7 from -7, we're gonna basically add it. That gives us 0. If we subtract -7 again, then we'll have +7. Because if you're subtracting negative, you're basically adding. So we'll do that, throw that in the outbox, and run. So let's see if that works the way I anticipate. -7, put it there. There we go, +7, and loop. Okie dokie. And another cutscene. I do not want to go on vacation with any workmates that I have had in the past. That does not sound fun. Okay, maybe one workmate. The ones that I'm friendly with, but not your standard people you talk to just because you work with them. Countdown. Now we have different hair. I have a little bun. Tick, tick, tick. Time keeps ticking down. Let's get to work. Oh, yes. I love what you've done with your hair. For each number in the inbox, send that number to the outbox, followed by all numbers down to or up to 0. It's a countdown, or count up. And now we have bump plus, bump minus. So in C++, that would be like variable plus or variable minus. It just decrements or increments, but not in that order. So unfortunately, this is where it's going to also be complicated because we have to account for positive and negative. So first we're going to grab 6 and put it here. We're going to put that 6 in the outbox. Then we need whatever is the next number down. So let's just think about positives first. Bumps minus, will just take that and subtract it by 1 in your hands, but it doesn't replace it there, so we need to overwrite it, put that value in the outbox, and keep doing this part until it's 0. So this is not complete. Let's just look at this though. 6, put it there, throw it out. We're gonna subtract 1 and grab it. Oh, we don't have to copy 2. It does subtract it just there. That's not needed. And then put the 5 there. And now we need to loop that. So we don't need that part. Let's set this to countdown. CT LWN. So we'll worry about the negatives later. When do we know if we're done with the countdown? If we're at 0. So if it's 0, I'm trying to think. We're going to... Actually, no, we want 0. I'm just thinking because we're going to have to grab that value back out. We do want a 0 to go out, so we don't want to stop it at 0. But once it goes out, we want to copy it back. If it's 0, then we're done. So we have an 8 here. Let's just make sure that works. So 8 goes out, 7. I did not loop the rest of it. So if it's not 0, I'm gonna keep bumping it down. 6, 5, 4, 3, 2, and so on. Now we have 0, 0 goes out, that's done. Okay, so now we need to account for negatives. We'll do the same sort of thing, except we have to count up. So this is our countdown. We'll have count up. We also have bad variable names, just like in C, because of limited space. So same logic, but we go up. Bump up, outbox, grab it again, check to see if it's 0. If it is 0, we're gonna reset. Otherwise, we're gonna keep on with this loop. Put it there. Okay, let's see if that works the way I intend. Oh no! Oh, you can't jump if negative with empty hands. Oh, oops. I guess we will copy from there just for now. Not efficient, but good enough. -4, -3, and so on. Ooh! Okay, if we pull a 0, which they'll probably have in there just to make sure we did it right, we're grabbing that. If we happen to have a 0, we've already put it in the outbox at this point. Grabbed it, copied it. If it was a 0, we're resetting. So, robot art in there. So we put that 0 out there, and the rest is done. There we go. Could have been fewer commands. Also, while we're here, this is what you would call spaghetti code. This is why you're not allowed to use goto or jump statements in like your C code, because it's ugly. And let's look at, where's my desktop capture? These are the commons. I guess that's just the text. So we have label ABC. I feel like I could be using the jumps better. I don't know how they're really intended to be used, but that's just how they make sense to my brain. So here's jump for 0, jump for negative, comment, bump down. So same. That's not what modern programming languages look like these days, but that is what older ones look like. I like that they also have a mute thing here in case you just can't think with that music. Okay. So, for each 2 things in the inbox, multiply them and outbox the result. Don't worry about negative numbers. Good. Now we have labels. Okay. So, last time I talked about the tripler problem, where if you have like 4 times 3, that literally just means 4 plus 4 plus 4. 4 plus itself 3 times is 4 times 3. So we have to use that same logic here since we only have addition. We do not have multiplication. So we're going to grab from the inbox and put it there. Grab the next thing and put it there. I'll do that. Let's say this is just variable A and this is variable B. What we want to do is keep adding A to itself B amount of times. So let's change this up. We don't want it to be A. So let's say we have the value I want to make this clear. So A times B. So this is going to be our A value. This is going to be our working sum, our running total. And this is going to be our countdown, which is B. It's going to start as B. So grab that. I am going to copy this here. We're going to count that down, bump that down each time until when we get to 0, we're done doing the addition. Okay, and let's see. That's supposed to be copy 2's. So we're gonna take A, we're gonna add it to itself and put it in the sum, that running total, or we can say running total. Okay, we add to itself, we put it back in here, then we bump down the counter. If the counter is 0, we are done, and we're going to outbox. Otherwise, we are not done, and we're going to repeat that. So let's just look at this step by step. We have 1 times 4, not the best test data. 1 plus itself is 2. Subtract that down. Yeah. But I don't have an out. Oh, yeah, I do have an outbox. Okay. Oh, I am not doing that right. Dang it, I shouldn't have done that. Let's look at that for that logic error. I keep adding 2 plus 2 every time, and not the running total plus the thing. So we're going to copy from here and add A. I'm going to copy the starting value into both of these, and the countdown, the second number, into the countdown, and we're going to keep adding to the running total. I had that wrong where I kept adding A to itself. So 3 times 2. We're going to take 3 plus 3 is 6, put it there. 2, 1. Well, that was 3 times 2, right? So I need to adjust my countdown. Also, it outputted the 0. Maybe let's do this bump beforehand. Because if it's 1, we do not need to change it. Jump if 0. Copy from our running total and put it out. Okay. So if we're multiplying by 1, then we bump it down. Then if that's 0, then we just put it back out. Let's see if that logic works. 2 times 4. 3, so we got 2 plus 2. Throw that in there. Oh, why are you doing that again? I need you to... Oh, well. I am not jumping at the right time. And we need to copy from countdown so we can reference it. 6 times 5. Okay, let's see if my logic is right this time. So 6 and 6, 12, okay. Not 0 yet. Okay, I do not need to copy it a second time, sorry. Okay, so 7 plus 7, 14. Next, 14 plus 7, 21. I did not look at what that original value was. I assume it was 7 times 3, because he didn't complain about that. Okay, once we outbox it, then we need to start over from the beginning. So let's check that out again. 8 times 5. Okay, so this is a little bit easier to follow. Well, oh, I did not account for a 9 times 0, or a number times 0. Uh-huh. So, if the countdown already is 0, let's just throw that in the outbox directly. Gotta account for the outliers. Okay, 5 times 4. That will be easier to follow, so you can kind of just watch this. So 5 is already added once. 5 plus 5. Okay, 5 plus 10, 15. That's times 3. 5 plus 5 is 20. That's 5 times 4. Now that's 0, so we're gonna output that. Okay. And then we'll watch this times 0 one. 4 times 0. That's 0. We're just throwing it out. It's fine. Now it's going to add 0 to itself a bunch of times. That's fine. The logic works. It's not efficient, but whatever. And there we go. Not the most efficient. We could account for zeros on either side, but since the code is so linear, I don't really want to do that. Educating our employees on the job here. Do you know what a zero terminated string is? I sure do. The inbox is filled with 0 terminated strings. What's that? Ask me, your boss. Add together all the numbers in each string. When you reach the end of a string marked by a 0, put your sum in the outbox. Reset and repeat for each string. So, I also talked about 0 terminated strings last time. So, we're gonna grab something from the inbox and copy. This is gonna be our running total again. And if what we have is 0, we're going to... dang it, I always use the wrong one. I don't know why. We're going to copy the value and output it. So this is when we're done. This is when we've hit null value. I know that's kind of hard. That's a /0. Okay. If it's not 0, we're going to copy that to run total inbox. I'm trying to think because we have our first value versus the subsequent values. Because we need to grab the next thing, add it to the run total, and then copy that to the run total. So we're gonna put this here. I'm just trying to think ahead a little bit. Grab the 2, copy it, grab the 8, not a 0, add it to the total, put it back in there. If we had more items, we would do that again. But if it's a 0, then we're just going to take that running total and output it. I'm not 100% sure on this logic, so let's just kind of watch it. So we got 2, add a 10, next thing is 0, so we're going to output that 10. Now we have 3 numbers, so 5, I'm going to grab this -6, add them, put it in there, take 5, not a 0, add them together, it's 4, then we have a 0. Let's just put the 4 in there. Oh, what if we have a 0? What do we do then? Do we just output that 0? Okay, he didn't mind that. Okay. Let's just keep running this. I'm always bad about hitting stop instead of back. You wanted a 0. Why? You wanted the 0 in there? I don't understand. Turn off that music. So she added that, put that in the output, right? Grabbed 0. Threw that out. Okay, actually, I think I know what it was, because there was a string of zeros together. There was like 3 zeros in a row. Which I'm not really sure what they want me to do with that, but if we grab a number, and that number happens to be 0, let's output the 0 and repeat. We'll see if that's what they wanted. Because see, here's the 3 zeros in a row. I don't know what they want me to do for that. Threw that out there. He was like, okay, that's fine. I guess we just output those zeros. But not if they're null terminating. Okie dokie. Let's see, let's get to the green area, and then we can take another break. The littlest number. To reduce our carbon footprint, management is requesting the smallest numbers only. Oh, good. For each 0 terminated string in the inbox, send to the outbox only the smallest number you've seen in that string. So, we're going to have to keep a list of what the minimum value is. Because we can't just say, oh, I read 3 things, look back over the 3 things. This one's smallest. We don't know how many items we have in our 0 terminated string. So, we're going to grab something, copy it here, and grab the next thing, copy it there. So let's just say this is A and B. So well, I'm not thinking about zeros at the moment. We're going to compare them. So subtract B from A. Let's just write that here so I don't get all mixed up. If that is negative, I guess I can put my stuff in here, I guess. If it's negative, I get so confused by this. Because that's not gonna skip this if I do that, right? I don't know, we'll see. Then we're going to copy from B, the smaller one, and put it in minimum. This is gonna be 6, 10, 10 minus 6. Otherwise, copy from A and put that in minimum. Let's just see if that does what I think it does. I'm trying to figure out how to use these jumps better. Grab. No, that's not the minimum. Grab 5 and put that in minimum. Okay, see, she's gonna do that anyway. So if it's negative, otherwise do this. Oh man. Okay. B minus A, negative. B minus A greater than equal to 0. Okay, I'll be out in a second. And I've been experiencing that office thing where someone literally just interrupts you and then you lose your train of thought. Okay, putting 8 in min. So then we want to keep doing that and grab the next thing and keep comparing it. Oh man, this music, man. See, this is where I want to do this in C++. Actually, that would be kind of fun. You want to do this in C++? Okay, let's take that problem and look at it in C++. So here's the comment, the instructions. I wrote a simple unit test that has some input and checks to see if the expected outputs are given. And then our stuff will be in here. So at the moment, let's just say we return the wrong stuff. Let's just say we return 11 and 12. Rerun it. Oh, I should probably make this a desktop capture so you can see the console output. It'll say error expected 1 but found 11. Okay, so in C++, we need to stop at the 0 terminating string. So let's say first we need a place to put our output, and say int min, and also let's have a int index is equal to 0. So we're gonna start this off, loop over every element of the input. For int I is 0, I is less than input.size, I plus plus. I guess I don't need this index here. Okay. If input at this position is 0, and this is the terminator. And at that point, if we have the terminator, that means we should have the minimum, the smallest value in minimum. I'm going to have to change this in a second, but so I don't have it currently being stored, but just logically. So output, we would add that minimum to there, and then continue on. So we also want to set the minimum to the very first item we see, and we will overwrite that as needed. So I guess I would tend to write it this way. Input 0 is the very first thing. We're assuming we're not going to start with a null terminator at any point. And then at this point we also want to put the minimum value at the next I plus 1. But let's say if I plus 1 is less than input.size, we're going to set min to input I plus 1. We can continue with the rest of the logic because it's not really going to affect it because we're going to compare it against itself. So we're going to look at item number 1. If the item at input of I is smaller than what our current minimum value is, we're going to update that minimum value to whatever that is. So let's just say new min found input I. And then over here is our terminator. It pushes back. Also, I'm assuming the strings should all end with zeros. We're not going to get just like a random 3 at the end or something. So at that point, let's return our output. We don't get to watch it execute nicely like in the game. Okay. Let's also add, I guess, I guess we could technically step through it with the debug. Let's look at everything it is reading. Element number I is equal to whatever value that is. Oops. Ah, this keyboard does not have the backslash where I expected. Okay. Let's maybe make this a little bit better. Last char new string equals true. So instead, I'm going to do this. If new string, then we're going to now set min to whatever this input value is. Sorry if I'm not explaining this great. I'm just trying to like clean stuff up as I go. Then new string is false. So this is just to set the minimum to the very first value of the string every time. We're going to not do that. And we'll say new string is true again. So we hit this terminate. Excuse me. Hit the terminator. So so first element of string, new minimum. Okay, let's see if that works out. Element 0 is number 1, first element of the string, so that's our min. Not smaller, not smaller. Oh, dang it. Okay, it's counting the 0, so if input I is, let's just put this here. Okay, first element is 0, that's our new mini, apparently. 2, 3, skip, 5. This is our new element, and it's a 5. We've found a new minimum, it's 4. We're gonna do that, return that. And then my validator does not return, it does not praise me for getting it right, but since it didn't display errors, that means that logically works, at least with my test set. So, see, it's much easier to implement this sort of logic where you have loops and not assembly-like code. Okay, back at it, I suppose. Alrighty, back at this. Let's clear this just so I can start from a clear brain. Sorry, I just resized the window to see it better. Now I have to readjust things. We're going to center on the screen. Okay. So we're going to, let's delete that and delete that for now. We're going to grab something, and this is going to be our first value. So that's always going to go into min because we don't have anything else to put in there at the moment. Then we'll grab subsequent values. Yeah, let's see. Next. Vals. If it's 0, then it has terminated. End of end of string. And at that point we can determine the minimum value and output it there and restart the whole process. Okay, but then the tricky part is, what do we do when it's not a 0? Compare. Let's say, is it a new min? Question mark. So we have that minimum. We're going to subtract. Well, we want to back it up just in case. So we'll back it up there. Back up. Okay. Let's copy to backup, not copy from. Okay. We're gonna back that up. We're gonna subtract it from the minimum. If we get a negative value, that means that new value is smaller. So backup minus min less than 0. Otherwise, backup minus min greater than equal to 0. Wait, did I do that right? I'm trying to think. Backup minus min. So, I'm just trying to think. If we get a negative value, then B is smaller. So we're going to copy from backup and put it in the new minimum. Otherwise, we really don't care. We're not going to overwrite that minimum. We can just continue on our way. So let's jump placements, man. We're going to reset. Wait, no, what are we gonna do? If it's minimum, we're gonna grab the next values again. And if it's greater than, we're going to copy to it min, and then also grab the next values again. And next value, if it's 0, then we do that. Let's see if that works. So we got a 3. We got our 15. We're going to subtract 15 minus 3. It's positive. Get rid of that. We don't care. Going to grab 1. 1 minus 3, negative. 1 is the new minimum. 0. Oh. She did not. Inbox. Why did she not jump? Jump if 0. Oops. We'll put that there. We'll put that right here. Okay. Okay. Now we grab 0, our terminator. Grab our minimum, put it out, and keep going. There we go. Okay. So that worked out. Yay! Okay. Last one, and then we have a cutscene. And then we'll be kind of at the last bit. What is the purpose of this assignment? Volume beneath staircases. We have to put the intern somewhere. For each thing in the inbox, outbox the sum of itself plus all numbers down to 0. So if it's 3, we do 3 plus 2 plus 1. Okay, grab our first thing. Put it here. Let's put this as running total. And we'll also need a countdown. So this is count down. Okay, so we are going to take this. We need to bump down countdown. Does she automatically grab that? I really don't remember. Yes, she automatically grabs it when she does that. So take that, add it back to the running total, copy that back to the running total, and then keep doing that until that's 0. So if we have a 0, we're going to copy from our running total and throw it out there. And reset. Let's see if that works. 3. Add a 2. 2 plus 3. 5. Okay, I don't know why she did that. I need to stop hitting the stop button. And... okay, what did you do there? So she has the 3. Bump that down, add it there. Put it in the running total. Oh, you need to keep... I forgot another jump. Okay. Then we need to keep bumping it down. Okay. Down, add that. 5. Add that. 6. It's 0, so we're gonna... oh, just throw that away, apparently. Put that in the outbox. I did the wrong thing again. Now that's a 0. Now we put 6 in the outbox. Okay. Oh no, what if it's a 0? Oh no! Infinite loop. Ah! Okay. If the thing is 0, input. If it's 0, we're just gonna throw it in the outbox immediately. We did it! Look. I didn't make something inefficient. Okay. What is going on? I have only worked till like 10 p.m. at one job. I never, like, if you're paid a salary, don't frickin' work late. At that point, you're just losing money. If you're gonna work extra, they better compensate you. Also, I don't know why that's an eyeball. Also, we're going to space? I have no idea what's going on. But it's spooky. Okay, well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that, 10 more levels to go. And they just keep getting harder. Okay, well, thank you for watching. I hope you enjoyed this programming excursion. We'll continue on another time. Bye-bye.